So what I'd like to talk about right now is heat and work, and what these terms mean, and also how these terms are related to how we think about the sign of these. So heat, firstly, a clear example is a heater. So the heating element gets hot, and as a result of this, the temperature of the cold water increases as energy is transferred from the heating element to the water. And therefore, as it goes from a hot element to a cool element, and this is through essentially the random motions of the molecules bouncing in, transferring this heat energy, this is called heat. And in terms of signs, we think about the system. If we think about the water as a system, and we have to always know what our system is, the water as a system would mean that it gains energy, and therefore, in this case, the sign of Q, the heat, is positive. Work, on the other hand, is associated with the systematic uniform motion of particles in a particular direction, leading to transfer of energy. And a particularly good example, for example, here, would be where I would have a gas piston and push on it. And if I push on it, then the work associated with pushing these molecules in one direction, this will be work, because it's not random motion, it is in the uniform direction. So let's think about, say, gas expansion. When the gas is expanded here, the molecules are pushing outwards. Since the molecules are pushing outwards, it is doing work on the plunger. And if we consider the gas in the syringe as the system, we would conclude that the system has done work on the piston, which is part of the surroundings. So it's done work on the surroundings, and therefore W would have a negative sign. Conversely, therefore, if the gas is compressed, then something's pushing on the gas molecules, and therefore W would be positive.